Okay, so I got a question from a student regarding homework 6.1, which was chapter 3, question 59. And first, at the outset, I'm going to apologize for the quality of this video. My kitchen is the most quiet place I can get right now, and my wife's cooking dinner, so that's the best we can do. Not only that, I don't have my tablet here at home, so I'm going to have to use my mouse and so on. But hopefully this will still be helpful. All right, so determine the empirical formula for a compound that has 70% carbon or 71% carbon, 9% hydrogen, 4.5% nitrogen, 16% oxygen, right? And it's going to be one of these three things. There's a few ways we can do this, but we have a nice routine that we can use for empirical formulas. And since I don't have my pad with me, I'm going to just show you what I would write down. I would write, on my paper, I would write element and the percent. So the first element that we're given, by the way, is carbon, right? How do you spell carbon? Carbon. First element we're given is carbon, right? That's right here, carbon. And what's the percent? The percent is 70.79%. Right? Can you see why I wrote the percent as that? I'm going to write you a couple questions. Why did I write 70.79% as 0.7079? Okay, and the answer is because they are the same, but 0.7079 does not have a symbol. In other words, it's the number. This really means that, okay? So it means most of it, almost 100% of it is carbon. That's what that means. So let's go back here. You might want to pause and go back and look at that and say, what was he thinking when he was doing that? So 70.79% carbon. So for hydrogen, what am I going to write here? Right? And what goes here? You tell me. What number goes there? It's 0.0891. Is that right? Let's move this over a little bit. 0.0891. Okay. I think that's a Zine right now. Hello? Hey, I'm fine. Hey, Zine, I am actually making a video right now as I speak, okay? So, but I don't have it with the pad. I'm just doing it with the Excel spreadsheet and so on. I wasn't sure if you'd be able to call me. I'm going to hang up on you and keep doing this video, and I'll send you the link in a little bit. But call me back if the video doesn't make any sense. Or if you need more help. Okay, talk to you soon. Bye-bye. All right, sorry about the interruption there. That was the student who was asking for the help. Okay, so what goes here? Nitrogen. And what percent goes with nitrogen? See it over here? 0.0459. And the last one's oxygen, so it's 0.1572. Okay? I would normally write this on my sheet of paper, but again, since I don't have my notepad, I don't have a way to write it on my screen for you to record, so this is what I'm doing, okay? So what's the mass then? What's the mass in this compound of this stuff? Well, we don't know, right? Because we don't know how much of this compound was given. But what I like to do here is I like to go, oh, wait, suppose we had 100 grams of the stuff. If we had 100 grams of the stuff, what would the mass be? The mass would be 70.79 grams, right? Because 70% of it, or 71%, is carbon. So how much hydrogen would I have there if I had 100 grams of the whole stuff? I'd have 8.91 grams, right? How much nitrogen would I have? 4.59 grams and 15.72 grams, all right? For each one of these things, you should stop and ask yourself why I'm doing that, because it'll make sense. Don't just memorize that we're supposed to do it. You say, why am I doing that? Because I want to know, here's the reason why, because I want to know the molar ratio. This is really the magic column. That's the magic column right there. Because it's the moles, these are moles, right? and so I need to know the mole ratio. So in order to get moles, I need to know the mass, and I've got the mass percent. So the formula weight of carbon is 12.011. The formula weight of hydrogen is 1.008. Nitrogen 14, I think, 0.01, and this is 16.00. Okay, so what's the moles? How do I calculate moles? From mass, multiply or divide molar mass, which I usually call formula weight. Okay? Right, I need the moles. I got the formula weight here. So I always forget this formula. So what I'm going to do is I'm going to say I need the moles. I got to come over here. You've seen me do this before in class. It must be moles over grams. Must be, looks like it's grams times grams over moles, right? That's going to give me moles. So it looks like I've got my mass times 1 over formula weight equal to moles. That's what's going to give me. Mass divided by formula weight. So here's my mass and my formula weight. So what I'm going to do is I'm going to say equals mass divided by formula weight. Oh, and you know what? You should do this on your calculator. I'm doing it with Excel spreadsheet, but you should do it on your calculator. This is the moles is equal to the mass divided by the formula weight. Do it on your calculator right now and tell me what is 70.79 divided by 12. Do it on your calculator, and actually you should go in and fill in all of these blanks here with your calculator because you won't have an Excel spreadsheet on your test, okay? So pause the video at this point, and when you're done, come back after you fill these in. Okay, so let me suppose you filled those in now. You've unpaused it, and there they are. Now what we do is we go through here and we divide. So these are the moles. If I had 100 grams, right? I suppose I've got 100 grams here. Suppose I've got 100 grams. Then if I've got 100 grams, 70.79 are carbon. If I've got 100 grams, this is how many moles of carbon I have. This is how many moles of hydrogen I have. This is how many moles of, okay? And so what I need to do now is I need to find the mole ratio. How do I find ratios? By dividing all numbers by the lowest. Okay, that's how you find ratios. Find a bunch of numbers, divide them all by the lowest. So which of these is the lowest? Is 5.89 the lowest? Is 8.83? That's the lowest right there, right? The 0.32. So I'm going to say, all right, I'm going to divide this by that. And you need to pause the video now at this point and do that. Divide them all there and fill in those on your paper. Okay, let me suppose you pause the video, and there's your answer. It's going to be 17.79. And this one is going to be this, or rather, sorry, this, oops, is equal to this divided by this. This is going to equal this divided by this, which is going to be 1, of course. And this is going to be this divided by this. Okay? So what are these numbers? Now let's reduce them or clean them up. What is that number? That's 18. What is this number? 27. That's 1. And what's this last one? Can you see it? It's 3. Okay, so what we have, the formula is C sub 18, H sub 27, N sub 1, and O sub 3. Okay, that's the empirical formula. Let's go back over here. C18, so it's one of these top two. H27, still the top two. And it looks like it's O3. All right, so hopefully that's helpful. Being able to find the empirical formula given the mass percent, what you're going to have to, let me review. What you're going to have to do is number one, how many grams of each element you have. Suppose you start with 100 grams of total. 2, figure out with molar mass or formula weight, I'm using those two interchangeably, figure out with molar mass or formula weight how many moles you have in 100 grams of total. And 3, reduce to find the mole ratios. If they don't reduce to even numbers, you have to figure out what fractions they go to. That's a longer question, and we'll do that in a separate video. Okay? Oftentimes they will reduce to whole numbers, just like they did here. You see how they reduced to numbers which are very nearly whole numbers. They were so close to it that we figured that that's probably 3, that's probably 1, that's probably 27, and that's probably 18. And we were right. Okay, I hope that's helpful.